Thank you from the Acting Vice-Chancellor, and thank you to all of the members of the University Executive who are here today. Thanks for your time, and thanks to our many honoured guests, amongst whom we have Nicole Lawler, who's visiting with us here today, a number of eminent colleagues from ANU and other universities in Canberra and from the public service. So welcome and thank you for joining us. As has been said, I'm Ross Thompson. I'm co-director of the Institute for Applied Ecology, and it is our great pleasure to host this year, in partnership with the Australian Biodiversity Council, the 13th Krebs Lecture. And as Jeff's indicated, Charlie Krebs has a long association with the university, and normally in normal times, pre-COVID times, Charlie would always have come and spent a couple of months with us each year, working with our students and our staff, and he's been an amazing mentor and indeed fulfilled the role of thinker in residence very well over a long time. Now, Charlie hasn't obviously been able to be with us this year, but he will have a short video message from Charlie at the end of the talk tonight. So the Institute for Applied Ecology was established in 2005, and over the last 18 years has established itself nationally and globally as a centre for challenge-focused environmental science. In its current form, it consists of two centres, the Centre for Applied Water Science and the Centre for Conservation Ecology and Genomics, and covers disciplines as diverse as glaciology and chromosomes. We take particular pride in the fact that we are seeking solutions to the world's pressing problems in areas like water management, climate change, conservation ecology, biosecurity, invasion biology, and Indigenous reconciliation. This year's been a really fantastic year once again for the Institute, with more than $5 million of research income and $14 million soon to be announced. The Institute has published over 100 peer-reviewed scientific papers in the last year, adding to a grand total of more than 1,000 papers. We've had 10 PhD students complete, including our second ever Indigenous graduate. And our staff have been active in contributing to the rollout of exciting new undergraduate offerings across the Faculty of Science and Technology, and it's great to see some of our undergraduate students here tonight. Clearly, we have brainwashed them effectively into coming out of ours. So tonight's speaker shares the IAE's commitment for excellence in research with application in mind. Professor Hugh Possingham is one of the world's preeminent ecologists and has produced more than 1,000 publications across the areas of conservation, mathematical ecology, and landscape ecology. He has a scarcely believable H-score of 158. Does make me wonder what I've been doing with my time, and has been a mentor and supervisor to innumerable students and early career researchers. Originally from Adelaide, Hugh studied at the University of Adelaide and Oxford University before moving to a postdoctoral position at Stanford and then a QE2 fellowship at ANU. He moved as lecturer and then professor to the University of Adelaide before moving to warmer climes in 2000 and shifting to the University of Queensland. At UQ, Hugh was, amongst other things, an ARC Professorial Fellow, Federation Fellow, and Laureate Fellow, which, as I understand, is the only person to have had all three of those eminent fellowships. He then founded and led the ARC Centre of Excellence for Environmental Decisions. In 2016, he was appointed as Chief Scientist of the Nature Conservancy, the world's largest environmental non-government organisation, before moving into the role of Queensland Chief Scientist in 2020. And if you give Hugh enough wine, he'll tell you entertaining stories about working with government in Queensland. Most recently, Hugh has retired, but he remains an active scientist, advocate, bird watcher, and granddad. Hugh is Chief Counsellor of the newly created Biodiversity Council and Chief Scientist of Accounting for Nature. So all that's awesome, but I actually think the following story probably says much more about Hugh than any of those accolades. As a second-year ecology student at the University of Otago, I was set the assignment of running a population model for yellow-eyed penguins, an endangered penguin species. It was late at night and I struck a problem with the software, and because I was young and stupid, I flicked off an email to Hugh Possingham, one of the world's most famous ecologists. And Hugh, greatly to his credit, replied kindly, without ego, and with some friendly help for a second-year student he'd never heard of before. And I think that really represents Hugh as a generous collaborator and colleague. And so it gives me really great pleasure to invite Hugh to the floor tonight to speak on how science and maths influences environmental policy, or maybe not. I think
on this. Thank you very much, Ross. Was my advice any use, though? I mean, it's one thing. It's one thing being kind. It's another thing being useful or useless. Thank you for that very kind introduction. Thank you, Acting Vice-Chancellor. Thank you, Richard. It's great to be here at the University of Canberra. This is my first ever trip here, but to be honest, I've always greatly admired the Institute for Applied Ecology. I think it was ahead of its time. Now there's no doubt about it. We're here to try and solve the problems of the world. We're in a mass extinction. Ecosystem services are falling to pieces. There's so many problems, and the fact that University of Canberra almost 20 years ago had a dedicated applied ecology group early on is extremely commendable. I'll say something briefly about that in a second. I would also like to acknowledge traditional owners around the country, and my work has spanned the whole country and overseas. So I will particularly just point out that I was born on Kaurna country, known by most people as Adelaide, and I acknowledge their ownership of the place I was born. 4 Possinghams arrived in Adelaide in 1852 and 1856, 2 on each of 2 boats, and I apologise for what we did to this country and the Indigenous people. I don't know exactly what they did. I do know they stole those people's land. The 13th Krebs Lecture, almost certainly unlucky. I'll say one thing at the beginning. It's interesting, when I first came back to Australia, I went to ecology conferences, and I was trained as a mathematician largely, and I'm known as a modeller and troublemaker. And I went to the conferences, and a lot of people at those ecology conferences, this is 1990, remember, it's a long time ago, said, well, you're a theoretical ecologist, so nothing you could be doing is useful, right? You're a modeller, you do theory stuff. That doesn't help. And I for a long time, and then there were very few modellers at the time. In fact, it was Ian Noble over at Research School of Biological Sciences who set up a group there of modellers and theoreticians. And I didn't really know how to answer that question. So I get things like the logistic equation and exponential growth. They don't really work, do they? Models don't work. And so I was embarrassed. So I had to get drunk. That's what you do at conferences. It took me a long time to realise, strangely enough, that if you're theoretical, it doesn't mean you can't be applied. If you're a modeller, it doesn't mean you can't be applied. And actually, more and more I realised the people who were saying that as a modeller I couldn't be useful were empirical ecologists who were pure scientists who didn't even want to be useful at all. I was at ANU, remember? Sorry, I shouldn't pick a name. I mean, there are lots of empirical ecologists who do applied work, but there's a lot of empirical ecologists who want to know why a cisticola has a short tail. And great, I'm very glad they do. But I was never interested in science for science's sake. I was interested in science for solving problems. And I would then say I'm a theoretical applied ecologist. And theoretical applied ecologists work with theoretical empirical ecologists. One of my great colleagues is there, David, and we'll tell some stories about David in a second. Factual or not factual, doesn't really matter. Bottom line is, it's the marriage, in fact, of modelling and decision science with empirical ecology that can sometimes influence policy. Now, Ian Cresswell, who's a good friend of mine and a public servant for a long time, sent me a little message saying, stories of how science and maths influence environmental policy. That'll be a 5-minute talk, right? And yes, what I'm going to ask you to do, I'm going to tell you some stories of how science and maths may influence policy and management in the lovely continent of Australia. And I'll tell you whether I think it worked or not, and you can try and keep score, and we can see whether we're ahead or not ahead in that. And of course, these are stories, so They're very short stories. They're full of errors and disclaimers and fault. In fact, everybody reflects on the past and makes themselves far more important than they really were. So just bear all that in mind. They're just stories. There's no science. And then I'm going to tell you the stories, and you might say, well, what's these stories? Just a series of stories. It's a bit like an Australian movie, right? You get to the end of it and you think, did that mean anything? Was I actually meant to tell good from evil? This isn't Hollywood, is it? So this is not going to be Hollywood. There is a series of stories. I'll tell them as accurately as I can. You can take home whatever you like from those stories. This is the Australian movie. There is no grand synthesis. I will say some things that maybe potentially run through as themes, like if you want to have a good career, find young people and exploit them as much as possible. They're called PhD students and postdocs. How do you get an H index of 158? You certainly don't write all those papers on your own, and give them lots of space. So the one thing I do, some people say I just don't supervise people properly. I like to interpret that I gave my students a lot of space to do what they wanted to and go and form collaborations where they want to with whomever they want anywhere in the world. Necessity is the mother of invention. So most of the things that have happened are accidents and occur because of meetings where I didn't really want to be and I was very, very bored. But I learned about the problems that state and federal governments and managers were having, and suddenly I realised that something I knew could be useful, but there was no plan. So I didn't sort of say, I just joined committees, lots of them. I'm on 28 boards and committees now. I've been on 105 boards, committees and advisory boards in my academic career, 105 separate ones. And almost all my academic colleagues tell me I've completely wasted my time, but almost everything useful I've done has come from those committees, even though 95% of those meetings have been incredibly dull. So maybe I'm sending mixed messages here, but if you are asked by a not-for-profit or a local council or an NRM body to help them, please say yes. If you're asked to be on a committee to advise them, please say yes, because it's an enormous privilege to turn up to those committees, and be patient, be very, very patient. So let's not draw too many conclusions before I go into the stories. I'm just going to run through almost chronological stories. And I came back to Australia very much as a theoretical ecologist. You know, I'd studied barnacle population dynamics under Jonathan Roughgarden, who became Joan Roughgarden. And when I arrived at Stanford, he said, Hugh, I want you to work on barnacles. And I said, what's a barnacle? I didn't know what a barnacle was. And one day I was modelling them. So I was very disappointed. I thought I was working on lizards in the Caribbean. You know, if you think you're working on lizards in the Caribbean and you turn up to a place and you're told you're modelling barnacles and you actually hate the sea and you can't swim, it's very depressing. Some people think I'm a marine ecologist now. So message number one is, if you're given a task that you generally think is inappropriate, impossible, and really, really dull, you will be surprised how often that is very, very beneficial. If you, as so many of my postdocs and PhD students, can pursue the career they want to without any constraints, then maybe you won't learn a lot. Maybe you won't learn it because you won't be pushed in strange and wonderful directions. After that, I came to Australia and I was interested in theoretical things, but it was a time when the forests of Australia were in dispute. The regional forest agreements were happening. In fact, the forests are still in dispute. Yeah, we've been doing this for 50 years, fighting about the management of native forests. Regional forest agreements were an intervention by the federal government to try and get the states to restrain and make their forestry more sustainable. And as you know now, that's playing out to the bitter end, which is basically, is pretty well on the wall. In the next 5 years, native forest logging will either have stopped completely or almost have stopped. So it's a very, very, very long process. And in part of that process, I started doing applied stuff. And one of the big questions was, if we're going to conserve enough leadbeater's possum, or powerful owls, or sooty owls, or koalas, how many does there need to be? How many do you need? How many leadbeater's possums do you need? 500, 6, 12. So, because if you don't know how many you need, you don't know how big the reserve system needs to be for Leadbeater's possum. So I wrote lots and lots of computer code, and working with David, I killed 1.5 billion possums in my computer because you have to run these models thousands of times with thousands of scenarios. So billions of Leadbeater's possums died in my Acer laptop. And then we tried to answer the question is what is enough to save Leadbeater's possum, greater gliders, other fauna, to inform the regional forest agreements. And in the end, we came to a great conclusion that the probability of extinction of Leadbeater's possum is a number between 0 and 1 inclusive. So I can say with certainty, ecological modelling tells you nothing with certainty. And the probability of anything happening is a number from 0 to 1 inclusive. There you go, that's a fact, mathematical fact. I'm safe on that ground. So it's a little bit annoying, right, isn't it? A bit frustrating. What's the point of modelling if it doesn't tell you what the probability of extinction of the species is under all these scenarios? But we learnt one huge thing, one thing which was completely unexpected, is even though we couldn't work out how to save Leadbeater's possum, and we still don't know how to save Leadbeater's possum or koalas, we could actually work out if we had certain amount of resources, what was the best thing to do for Leadbeater's possum? So should we stop salvage logging? Should we change the rotation times? Should we have small reserves or big reserves? All those questions we explored. And we found out the best reserve design for Leadbeater's possum under certain set of circumstances, and we could advise the Victorian logging state government and logging industry to adopt those precautions. It actually didn't tell you whether or not you were saving the species or not. It actually told you if you're going to actually forego some resources, this is the best thing you could possibly do. And that's huge. That was a fundamental change in my life. And for a long time, not many people in Australia do a lot of population viability analysis. But it was actually realised that searching for exactly what is enough is a very, very difficult thing to do. But what you can do that is best is easier, much easier. And the solution was robust to all changes of parameters pretty well. So it's a little bit like saying, what career do you want? You could advise people, I want a career that makes me $500,000 a year and gives me enormous power, and I can play golf every morning. That's the career I want. I can't actually tell you what to do to get to that career, but I can possibly give you advice to give you the best career you can have, because not everybody can earn $1 million a year, and not everybody can play golf every morning, and why would you want to play golf anyway? So in fact, advice about what's the best thing to do is far more important than given the constraints that we all have in our lives, then what is the advice to give me a certain particular outcome? It's very, very difficult to do. And that turned me, and I was fortuitously in a maths department, and the people who taught optimization were all on sabbatical, and I ended up teaching all this optimization, which I didn't want to do. I had to teach optimization, mathematical programming to third-year maths students, and I learned something, teaching courses I hated with a passion. I was a sabbatical in Imperial College, and I suddenly realised that the tools of decision science had virtually never been applied to conservation problems. And this Leadbeater's possum work and this forestry management work had made me realise that the task is, given a certain amount of resources, how can you do the best you can for nature? How can you do the best you can for nature given a certain amount of resources? And I would say of those 1,000 papers, 500 try and do that. And then you might say, did any of them work? Well, did the Leadbeater's possum and the greater glider stuff work? David might give us 3 out of 10 for that effort in terms of impact. Now maybe we're getting up to 8 out of 10. It had some impact. So maybe it wasn't incredibly important, but it started us on this path to look at viability. But as part of that process, the regional forest agreements, the other big question was, if we're going to dedicate more reserves, where should we put them? Where should we put the reserves? And at the moment, at that point in time, a lot of organisations had spatial planning tools, very good spatial planning tools, often very expensive spatial planning tools. So there was a guy called Andrew Taplin who said, can you build us a spatial planning tool that will help us work out where to protect in the forest? Which bits of all these state forests should be protected areas? Then I had a PhD student who'd come to Adelaide. His name is Ian Ball, and he had no scholarship. He was following his wife, who did have a scholarship, and he couldn't get a grant because he had a 2A honours degree. So I said, well, federal government will give us some money to make some spatial planning tools for forests, and that'll pay for your... So again, bad situation. Necessity is the mother of invention. He wrote some software called SpecSan. That software, SpecSan, started working on spatial planning for the regional forest agreements, was never used. Never used. So we've got a half and a 0 from our two influences of maths and science and policy. Remember, does maths and science influence policy? A half and a 0. A little bit later, having made this software free, so everybody else made software and tried to sell it or license it or contract you out to use it. We just put it up on the web and trained people in it, said it's all free, you can do what you like with it, and wrote papers about it. At that time, the Great Barrier Reef, Senator Robert Hill was the Environment Minister, the longest standing Environment Minister we've ever had. It was Environment Minister for 6 years. They were rezoning the Great Barrier Reef, and the Great Barrier Reef Marine Park Authority came to me because they thought I was a marine ecologist, which I wasn't because I can't swim. I didn't know anything about barnacles, but they came to me and said, you know about spatial planning, don't you? So maybe your tool, you could tell us how to rezone the Great Barrier Reef. And our software had been used for forests, and said, well, that can't work in the sea, can it? Software for spatial planning can't work in the ocean if it's for forests. And they said, here's $5,000, can you rewrite it for the sea? And so we took SpecSan, SP, what's short for spatially explicit annealing, and then we did rewrite it a bit, and then we changed its name to MARXAN, M-A-R, Marine, X-A-N, which doesn't even mean anything. It's not an abbreviation or anything at all. It's just a name that if you Google it, you get our software. And I said, this is for the Great Barrier Reef, and they were happy. They had tons and tons of data. We started to do spatial planning for the Great Barrier Reef, and that basically underpinned the rezoning of the biggest systematically designed reserve system in the entire planet. What does that software do? So message one is names are important. And marine and terrestrial ecology are not that different. And why do all the ecology organisations around the world have marine meetings and terrestrial meetings? And even the reef people, the temperate reef people, tropical reef people, anyway, it drives me up the twist. Stop going to meetings about tiny topic areas. Not doing you any good. And marine people, turn up to ecology meetings, please. So we built the software, it was deployed. What does it do, that software? So it's over 1,000 lines of code, optimization. It uses integer linear programming, things called simulated annealing to find good solutions to protected area system. Do you know what it does? It solves a problem that is 3 lines long, that has about 7 symbols in it and 5 parameters. It's very, very simple. What's the problem that MARXAN solves? It says, let's take the Great Barrier Reef. It has 5,000 reefs, 12,000 places between the reefs. Could you pick me a subset of those 17,000 places, a subset of those 17,000 places to ensure that 20% of every habitat and species is reserved, it's compact and well connected, and annoys as few people as possible? So that makes us a social scientist now, doesn't it? So we're a mathematician, an ecologist, and a social scientist. So that's what MARXAN does. It solves that verbal problem. It turns it into maths. For a long time, for 2 years, the Great Barrier Reef Marine Park Authority ran our software without any economics and social sciences. So they solve the problem, conserve 20% of everything, well connected and compact, but don't ignore people entirely. Ignore the fishing community, ignore the Indigenous community. Just give me a pure science solution. So fail, because they were coming up with ridiculous answers that nobody was ever going to implement. So it took me 2 years to convince them to actually put people into the problem. What's that mean is if you try to protect a part of the sea that is one of the most profitable areas for fishing, or worse still, try to protect from recreational fishing a place where the uncle of somebody, some MP, likes to go fishing on Sunday or aunt, it's not going to happen. It's not going to happen. But if you know all this information, you can build a protected area that minimises the impact on everybody else, and the protected area gets implemented. So eventually these things happened. The software was implemented. It's a very, very simple piece of software, solves a very simple problem. And it's that point or other that I reflected back. I looked at our work on population viability analysis, which is building a process model to help a species, spatial planning software, Marxan, which designs protected area systems. And I also reflected on the fact that although those pieces of software deliver solutions, those solutions were never implemented from the machine. The computer doesn't tell people what to do. They just provided initial advice that then was fiddled with and then refined, it runs through the software again. You go backwards and forwards, and eventually you ended up the rezoning of the Great Barrier Reef, the world's biggest systematically designed protected area system, 2004, July 1st, I think. And it did conserve basically 20% of every ecosystem type. So what was the important thing about the software? It wasn't the algorithm, it wasn't all the maths. This software is like a coffee table. Why is a software like a coffee table? Because the software demands a whole heap of inputs. Where are the habitat types? What kinds of coral reef are there? What are the distributions of major iconic species? Where do people fish? How much money do they make? So the software forces a group of people answering a complicated problem, which is designing reserve systems from the Great Barrier Reef. It brings them together to answer a common set of data and process problems, and they have to set a target. How much do we need to conserve? Is it 5% or 20%? Should every species get the same amount? And they have to answer all that. So in fact, the software itself is useless in many ways. It doesn't even matter if you ever run the software. It doesn't matter if you run the software because everybody's focused on the problem and the mathematics of the problem and getting the data to put into the software, and then you run it and you do get some answers out, and they're pretty good answers, and they're a good starting point for the rezoning process. Let me now contrast that with a situation. So we're going to give me a half a point for the Great Barrier Reef rezoning. They sort of, half, not one, because they fiddle around with it a lot, but we did get 20%. This was the first time anybody had built a global marine reserve design system that was properly representative. What is the fundamental of conservation planning? It's to get a bit of every habitat type to a reasonable level. And literally, I think one ecosystem, a couple of ecosystems were down to 19% out of over 100 features were mapped. And 33% was conserved altogether. A little bit later, the federal government decided to build marine parks across the whole of Australia. So again, Robert Hill was behind this. By this time, new ministers were in. There was a National Oceans Office. We were going to rezone the entire exclusive economic zone. How big is the entire exclusive economic zone? I think it's something like 9 million square kilometres, bigger than the continent. Continent's 7 million square kilometres. This is potentially the biggest, well, this is probably the biggest rezoning that's ever happened in one fell swoop. The federal government department, I said, well, you used Marxan before. We just delivered what is now the most iconic marine reserve and now been copied all over the world. The Brazilian Amazon was rezoned with Marxan. Protected area system was built. The English Channel. In South Africa, this software that was half Ian Ball's PhD thesis is used by all their local governments to do their planning on protected areas. Gabon, a gigantic country in the middle of Africa with 3 million people, build their forest protected area system with the software. It's actually changed about 5 to 10% of the surface of the planet in one half of one PhD student. I went to the federal government to help them with their federal marine reserving, and they said, we're not going to use this software. It's a black box. How black is this box? I told you what the problem was in one sentence. Get me 20% of everything in a way that annoys as few people as possible in a reasonably well-connected system. And you need some conservation features. How black? It's black, okay, it's 1,000 lines of computer code. That's black to people who can't read C++, but it's not black when you define the problem. And so they decided that they would contract out other organisations, and they just come up with broad areas of interest, and we make some protected areas here and there. Actually, the people they contracted started secretly using mark sand. And the reason why they didn't want to use mark sand, they said after the Great Barrier Reef rezoning, the compensation package for buying out the fishing effort, or some of the fishing effort, was I think $300 million. It was quite expensive for the day. They said we can't use that because it's too expensive. What did mark sand do? It minimises the impact on all other industries to achieve those goals. So that 300 was basically the cheapest you could possibly get to conserve 20% of everything. It's the objective function of the whole software. The fact we paid them out is brilliant. It's a huge, important move for that government of the time, because if you don't pay them out, all that effort gets displaced. So you need to pay people out. But then I had federal public service coming to me and saying, no, it's too expensive. Your software causes problems. So what did we get? We got one of the worst reserve systems in the world. For example, I could show you a map, but I won't. The northwest of Australia, the Kimberley region, has a is a huge area, a vast area. Again, the Great Barrier Reef is the size of Italy. The northwestern shelf is bigger than the size of Italy. Most of it is shelf, and they conserved about 10% of that. About 10% of that region is abyssal plain, and the rest has gas and oil interests. They conserved the 10% that had no gas and oil. And I know the abyssal plain is a lovely place. I'm sure, who's the marine scientist? There must be marine organisms in the abyssal plain. It's 3,000 metres deep. The rest is shelf, 40, 50, 100 metres deep, with all the biodiversity. They basically put almost no protected areas in them. Why? Not because they didn't use mark sand, they just didn't use anything. They hadn't got a problem. They didn't have a software. They didn't have a way of getting people to the coffee table. They had no rules. So that's another 0, I think. One day we made some of the protected area rezonings. Tasmania was pretty abyssal and abysmal. Southwest was a bit better because Pew contracted us to do a protected area system, at least put something on the table. It is not all lost. They will have to rezone our federal waters. Of course, we go to conferences overseas saying we protected 20%. We meet our Aichi targets. I think we almost meet our Montreal Kunming CBD targets. We've conserved 20 or 30% of all our oceans. Exactly, it's a 20 or 30% that nobody wants yet. I mean, they'll do deep sea mining one day, but basically has had almost no impact on any form of industry. So there has stopped no threat. And now is just, what do we do with this reserve system that we need to monitor and manage? And it's not even an issue. So some of these things go badly. Hopefully it will all have another chance to have another go. So another message is, if you live in a country and you try and deliver and say you're an expert on something to your government, they won't believe you. So go away. And if you want to influence the Australian government, do it from London or Paris or New York, because then you're an overseas expert. That's an expensive option. One of the other things I was doing almost exactly the same time, I was called into a meeting in the Federal Public Services, and they were talking about, this was a day when we used to fund threatened species. Federal government used to actually pay for recovery plans, lots of money, tens of millions of dollars. They had an active process. And they were trying to prioritise Australia's threatened species. Now, we have 2,000 listed threatened species. These are species that are likely to go extinct in the next 20 to 200 years, 2,000 of them. We're losing a vertebrate every 2 or 3 years now. We're losing a vertebrate every 2 or 3 years now. Went to the meeting and they said, we can allocate. Means we have critically endangered species. They're very likely to go extinct. We have endangered species. They might go extinct in the next 100 years. Vulnerable species, they're probably not going to go extinct, but they're certainly in decline. We better spend, and then we had the meeting, Mark Bergman was there, a whole heap of scientists, and at the end of the meeting, they basically were going to spend all their money on the critically endangered species. And I said, you know, that northern hairy-nosed wombats, which we actually have somewhat recovered, good, well done Queensland, gone from about 80 or 100 to 200 or 300. I mean, if we spend $10 million a year on northern hairy-nosed wombats, we can save them. But, you know, for $10 million a year, do you know how many plants I can save? 200, $50,000 a plant. 200 plants or one northern hairy-nosed wombats? Okay, who's going for the plants? 200 plants, hands up. No, 200 plants, hairy-nosed wombats, hands up. Yeah, we're split. Most people aren't willing to make the decision, wise people. Yeah, so it's a difficult decision, but I said maybe you should think of not just spending all your money on the species most likely to go extinct. Why don't you take into account the cost of the recovery project and the probability that the recovery project works at that cost? And I've got a formula for you. It's called cost effectiveness. It's expected species saved times probability of success divided by cost. And I said, no, that's triage. The public will never allow us to let species go extinct. We can't do that. We have to spend all the money on the critically endangered species. Well, that's worked well, hasn't it? So we're losing a vertebrate every 2 or 3 years, and we have been for the last 50 years. Whatever allocation method we're using, which now is actually none because we don't seem to spend much money on threatened species, not going so well. So what does an academic do when they're thwarted? They go and write papers. So we wrote lots of papers. And I had a great PhD student called Liana Joseph, and she wrote some papers. New Zealand looked at that work and some other work that we'd done and said, we're going to do it because New Zealand has 2,000 federally listed species and their economy is slightly smaller than ours. So they do have to make tough decisions. And they ran and they said, everybody said, you can't do this. And they ran all their top 600 threatened species through a cost effectiveness analysis. And they realised that they could now save 400 species instead of 120 species using cost effectiveness. They almost tripled the number of species they could save, and they've deployed it and implemented. And not only have they learned a lot about the cost of actions, because this formula is something that ecologists never want to talk about. This formula in these days was all about the cost of different interventions and what is the chance they work. So they had to put that into the formula. It's benefit times probability of success over cost. And then because they estimated it and they recorded it, they know a lot about the probability of what's the probability a 1 kilometre predator-proof fence works. What's the probability? How much does it cost to get all the possums off an island of 150 hectares? Because the formula, the model, it's not the maths, it's the formula, brought them to the table to answer a common set of questions. So they deployed that, and then after they'd done it, because they're smart, New South Wales did it. And then I went up to Queensland because I was living there. So New South Wales, their Save a Species program, people would say to me, you know, Hugh, if you have these cost effectiveness formulas, it'll make it acceptable for governments to defund threatened species. I spoke to the Director General of New South Wales Department and the Minister in New South Wales and said, I'm going to give you a formula that will maximise the number of species you save for an increased budget. They gave them $100 million. So everybody says you talk about triage and prioritisation, you'll get less money. My only evidence is no, you get more money because the people who have the money want to know. Don't come to me with a plan for $2 billion. No, tell me what can I do for the money I have, and then they give you more money. And they give you more money. So I'm going to count that as a 1. Not that we're saving many species, but somebody implemented the policies. Went to Queensland, they say, we already have a formula. We have a formula for prioritising threatened species. It has 7 components. We take the cost of the project and turn it into a number from 1 to 3. We take the probability of success and turn it in a number from 1 to 3. Then we look at how taxonomically distinct it is, a few other biological characteristics. We have another set of scores. We have 7 scores, and then we add them up. And they say, why is your formula better than my formula? And I said, well, because it's maths. And I went away, and then I came back and I got annoyed and frustrated. And then I said, is force equals mass plus acceleration? No, force is mass times acceleration. What is 3 meters plus 2 seconds? Okay. Not a very good educational basis here. Nobody knows what 3 meters plus 2 seconds is. They were turning dollars and probabilities and biological attributes into scores and adding them up. Cost effectiveness, somebody invented currency, 630 BC, Kronos, I think, in the Hittite Empire. We'll have a currency. As soon as you invented currency and started using it, then 1 billion people every day use the cost effectiveness formula. They go to the shop. there's 3 kilograms of rice for $10, or there's 4 kilograms for $8. What am I going to do? You know, I do kilograms per dollar. I don't turn dollars into a score out of 10 and add it to the kilograms. Does anybody here do that when they go shopping? And if, you know, somebody doesn't like a particular kind of rice, do I turn that likelihood of success into a score out of 10 and add it to the kilograms and the dollars? No. It took me, I think it's now 11 years, and just last year, Queensland government decided to adopt a rational approach because they contracted CSIRO, and they were my former students, and they made them use the cost effectiveness. So what's the other thing is, not only do you make yourself look good by having lots of brilliant students, they go into positions where they can do smart things with numbers. Now, how's my time going? Because I don't want people to miss out on their dinner or snacks. Oh, excellent. That's good. I can tell more apocryphal stories. Okay. The most important thing about that is literally a very simple formula. It's not complicated maths. Can solve cost effectiveness, cost utility analysis, can solve lots of problems. And people say, the other final thing is people would say, Hugh, but that's cost benefit analysis. There's costs and benefits. You're an economist, and the economists destroyed the planet. Well, no, the economists did not destroy the planet. They gave us the tools to destroy the planet. But they actually we destroyed the planet. We destroying the planet. They just told us how to do it cost effectively. But so often people say to me, but you're turning species into money. No, it's benefit, species saved, divided by dollars. I'm not adding species saved to dollars. So everybody did physics, right, somewhere, you know, year 10 physics, and you were told you can't add meters to seconds. You can't add probabilities to dollars to species saved. You can't do it. But how come there's 1,000 NGOs and 1,000 governments around the planet creating spurious scoring systems to prioritise investments in nature? Tell me. And intriguingly, New Zealand decided that this formula that people shop with billion times a day in the highlands of New Guinea to the mountains of Peru, this formula that almost everybody intuitively knows, they decided to reorganise all the New Zealand camping and hiking infrastructure around cost effectiveness. So they said, we have huts and bridges and trails and tracks, and we have to spend all this money fixing them all up. What if we take a cost effectiveness approach? How many people use that trail? Can we actually turn a trail or a hut or a new bridge into a benefit to hikers and campers, and then look at its cost and its maintenance costs? And they just actually bigger impact than our work on threatened species, because it actually deployed 20 times as much money because it had a simple formula for maximising benefit divided by cost. So I annoyed the government so much, they had to give me money. And they gave us 3 centres, the Department of Environment. So that's the other thing, is you turn up and you try and help people solve problems, and then you are a little bit annoying, and I am not just, I'm very annoying. You get research centres. So we had a SURF, a NERP and a NESP, the Threatened Species Hub, altogether about $45 million from the Department of Environment, competitively allocated. And then you might think, well, that's good. You're working closely with the federal government. So you go in to Canberra and also the state governments, talk to them about their problems. And the one thing in one of our centres, it was a NERP centre, we said, we really are very interested in the issue of biodiversity offsets. This is around 2006, 2007. Sarah Beckersey, Brendan Wintle, Martine Marin were involved in this process. And we said, we think we should do some research on biodiversity offsets, because the Federal Government Environment Act, the EPBC Act, that act demands offsetting. And we're not sure that offsetting's going so well. We don't think we're delivering net zero losses to biodiversity. And they said, no, please don't do research on offsets, because it's going to upset us. It's in the federal policy. So what did we do? We just ignored them and we used their money, and we did lots of research. We had workshops. We came up with a lot of good ideas on offsets. But of course, every time we talked to them, the doors were literally shut. No, this is you cannot even discuss this topic in polite company. And then, incidentally, several years later, they came to both Martine Marin and I and said, we have to redo the federal government offsets calculator, and we've got 3 months. Can you fix it for us? And they gave us 3 spreadsheets. They were light blue, orange and olive. And we looked at the 3 linked spreadsheets and we realised their offsets calculator was a disaster. It had multiple arbitrary rules. There were about 20 abstract decisions, like the importance of connectivity. What is offsetting? Offsetting means you decide to build a McDonald's on a piece of pristine vegetation. Sorry, I shouldn't pick on McDonald's. Some fast food place in a pristine piece of vegetation, destroy 10 hectares of intact vegetation. You need to now make 30 or 40 hectares of poor quality vegetation. Now you can already see offsetting is a bit of a stupid thing, but there you go. It's the one way of allowing development under extreme circumstances when, in theory, all the other options have gone. In theory, all the other options have gone. So there's a lot of offset going on. There's offsetting going on at every state and federal level. People are destroying habitat for threatened species, destroying habitat, and they're promising to restore it in other places or improve vegetation. None of it's actually particularly worked. But it's interesting. We said, we think we can solve that problem for you and we'll do it for free. They wanted to pay us money. And we looked at their linked spreadsheets. We realised that none of the formulas made any sense and there were many, many arbitrary decisions that couldn't be justified. And we actually wrote 2 or 3 papers. Megan Evans was involved. Several people in the public service were involved. James was involved. James Trezise, who's here somewhere, a new employee of the Biodiversity Council. And we gave it back to them with all completely different formulas, but we kept the colour scheme. There was orange, there was light blue, and there was olive, and they were very, very happy. And they implemented that, and so you can count that. Can we count that as a 1? So, you know, make sure you keep the colour schemes on federal government processes. But to be honest, offsetting, like, I know this is being taped, but offsetting is shit. Every time we do an inquiry into biodiversity offsetting in this nation, whether it's Queensland, South Australia, New South Wales, Victoria, we find out that we actually are not returning to nature what we take from nature. The whole thing has to be fixed up. The fact we can make better formula hasn't solved the problem, and this is obviously an interesting challenge for the current federal government and all the state governments. What is the message from that? Do co-develop with end users, whether they be NRM bodies, local councils, governments, industries. I've worked with Western Mining. I work with anybody who wants to genuinely solve an environmental problem. And I feel as though I have some skills to help them with. But you don't have to be their slave. You don't have to obey all their rules. And if they tell you not to do something, that's probably the best thing you could possibly do. That's the best thing you could possibly do. Because most of these organisations want to solve problems that they have in the next year. And most problems, genuine research problems, cannot be solved in a year. So the fact we did 6 years of work on a topic they didn't like enabled us to solve a problem in a few months with the help of the public servants in place. The final thing I'll briefly talk about, which is a somewhat similar story, is the Threatened Species Index. The Threatened Species Index was a product of our last hub, the National Threatened Species Hub. And I was the director of that hub. We had a good sum of money to work on threatened species. Greg Hunt, bless his cotton socks, was a very big advocate for threatened species, former Federal Environment Minister, and he really wanted to save as many species as possible. I actually genuinely think he thought we would go and put up nest boxes. I said, these hands don't put up nest boxes. They're delicate, soft little white hands. But all we do is research. So we'll deliver research. And one of the projects we put up was the Threatened Species Index. You can Google it, get bored. If you looked at it on your computers, you can do it at the moment, your iPhones, tsx.org.au. And it was meant to be like the ASX for Australian biodiversity, the TSX. So there's a bit of marketing going on here already. Put that proposal through. It was actually the only project in that hub that I was championing. We had lots and lots of projects, lots and lots of people. And I said, I really think it's sort of time we actually knew how well our threatened species were going. And it relies on getting annual counts of any organism, plant, mammal, bird, from a particular place, counted in the same way, and putting it through a series of mathematics gives you an overall trend for Australia's threatened species. And, no surprises, since around about 2000, Australian threatened species have been declined 2 to 3% per year. So the threatened species index, which started off at 1, is now, I think, 0.51 or 0.48. You can Google it, and you can do the birds, you can do a particular state. So I took that as a proposition. I said, we're just using the maths of the Living Planet Index, time series analysis. The board hated it. The federal government hated it. The people in Erin, who were the data people, said, this won't work. You won't get every species. There's 2,000. I said, I know, we won't get every species. We ended up, I think, so far with 300. You won't cover the whole of Australia. So basically every argument they said, this won't work because you don't count every species in every place in a continent. 2,000. So they stopped it, and we struggled, and finally we got it through on multiple meetings. Nobody still liked it. We had enormous support from the states. We have enormous support from Bush Heritage Trust, Australian Wildlife Conservancy, lots and lots of data. 14,000 time series of threatened species, 14,000 covering a lot of species, telling us a grim picture. And what's the use of it? I mean, that's just monitoring for monitoring's sake. Why would we have such a thing? It's just, when Graham Samuels did the review of the EPBC Act, he was talking also again to Martine Marin and myself, and he said, this is the person in charge of reforming Australia's environmental legislation. They had a big review. We'd done one in 2011, the Hawke Review. We all made lots of submissions. David and I again, and several people here must have been involved in the Hawke Review. What happened after the Hawke Review? Nothing at all. I didn't even get a response. We all put in hundreds of hours of work. Samuels did the Samuels review, and he said at the beginning earlier, I said, oh, are threatened species really in trouble in Australia? You know, is there really a problem? And this guy is a super smart, I think he's a lawyer. You know, these people can read. And Martine opened up, they opened up the laptop and said, this is how Australia's threatened species is going. And it's sort of hard in this room for us to believe that anybody, any intelligent human being in the continent of Australia did not know there was an extinction crisis. Literally, from their own observations, from the fact we're losing all these species every year, the abundance of organisms, the fact we have 2,000 organisms. Opened up the laptop and said, this is the threatened species index. This is 14,000 time series. And he never bothered to ask the question again. Has been now an incredible advocate for the environment, an incredible ally to the environment movement because of one graph at one time. And then most recently, our federal treasurer, Jim Chalmers, yes, say yes, somebody say yes, that's our federal treasurer, yeah. He released a report. So this is an index that so many people tried to not make happen, went out of their way to stop it. They released 50 indicators of the state of the nation that are not economic indicators: health, unemployment, housing. There was one biodiversity indicator. That's the threatened species index. Only one. Now it's not perfect. It's not even great. It's pretty good. Why did it work? Why did it actually happen? It's not because of me. It's because I employed Elisa Baraktarov, Misha Jackson, Aisha Talek, they're all women with names that end in A, and Jeff Hurd, he's the anomaly, and Taylor. They basically had so much passion and drive to ring up all these researchers and state governments to get their data, and people said, no, what does a state government always do when the federal government or any agency asks for data? They say, give me money, and you didn't pay for it. And I'm angry with the federal government. Anyway, because we weren't the federal government, we managed to collect an enormous amount of data, and the threatened species index is booming and now hopefully informing policy even more. So I'll reflect on a couple more things. You know, I'll try and leave, so I should leave on an optimistic note, shouldn't I? That's what you're meant to do in a talk. I have to say, as now a biodiversity counsellor and being involved in, I do wonder why we make so many submissions to federal and state government inquiries. Who's made some submission sometime in their life to any sort of, and do we really feel as though it's helped? So we do make a lot. And I wonder, are actually submissions to government inquiries, are they just a joke to keep us busy so we don't go and join the placards on the street? I don't know. Maybe they are, maybe they're not. Sometimes I think they are useful, but it is depressing from this side of the bench, and I have been a public servant for 2 years. It is very depressing, and I've delivered public service reports. The last one on land clearing in Queensland, we finished it in November. What's the Queensland government done with it? And I mean, released it. I briefed 2 ministers on it. They just released their land clearing reports. A report by 9 people, 10 people over 9 months on the state of how to stop land clearing in Queensland, the most important environmental issue in the nation. Queensland state government sat on it for 8 months, 9 months. So, yeah, do submissions, yes. Join committees, yes. But in the end, if we can't get actually governments to be a little bit more transparent about their processes and release this information much better, we'll never get anywhere. So what does work? What does work? I've given you some examples of policy interventions that do work, that's informed by maths and science. But sometimes lobbying is the best thing we can possibly do. So sometimes you have to step outside the box, go in and out of the box. Educating people and training people is probably the most, I don't think I've done very much, but the fact I've had 92 PhD students, almost all of whom are very smart, dedicated environmentalists who are in there working for government, NGOs and universities trying to change. That's by far the most important thing I've done. And I'll end on one thought, which will lead into question time. So the only reason I've been able to achieve anything at all, and it isn't very much, is enormous privilege. So what I like to do now is reflect on the fact that there is a wheel of privilege. There's 16 dimensions of privilege, and I am on the top of 15 of the 16 dimensions of privilege. Gender, race, sexual preference, education. My mother had a PhD in physics. Okay, who over 60 here has a mother who had a PhD? So massively overeducated, massively privileged, happy family, all these privileges. 99% privilege, 1% hard work. To that end, I'll just say it's all very well reflecting on all your privileges, and you should all reflect on your privileges. And I doubt anybody here is as privileged as me. But your job then is to fix people who don't have those privileges, right? How can you work out? Don't ignore all your privileges. Count them. Find the paper that identifies the 16. And, you may only have 9 of them or 12 of them. But you need to work out how to fix those lack of privileges. And to that end, I will start questions, and I'll start them, and it can't be a question from a Caucasian male. How about that? The first 3 questions, no questions from Caucasian males. Not that I pick on them because I am one.
All right.
But,
yeah, great. Thank you. Maybe we'll just have a round of applause for thank you very much before we get rolling. Thanks very much, Hugh. That was a wonderful look at science and policy, maybe a bit of a Mad Max romp if we're talking Australian movies. We do have questions now for Hugh, and we should have some microphones floating around for the first question. Diane, you're not Caucasian male, so... Here we go. There we go. Great.
Here we are. I met the brief. Thanks, Hugh. That was really amazing and really super interesting, your reflections. I suppose, I think, there's enough of us here that have suffered the frustrations of trying to influence policy to government agencies. I'd like to just see what your thoughts are on where the private sector is perhaps heading in the corporate world, and particularly with the impending release of the task force on nature-related financial disclosures, which is coming at us like a steam train, I believe, release next month. And yes, how do you think that might change the landscape a little?
Yeah. So I sort of vote with my feet to a certain extent, because Accounting for Nature give me a salary of 10%, and Accounting for Nature is a not-for-profit that's designed to play into those nature positive type things that industry and should eventually be developing. So a lot of this is based on first of all, a contentious fact or contentious issue. One is, I spent 30 years, 40 years trying to convince government to spend enough money to save the environment. What has Australian environmental spending done in the last 40 years? Gone down across state and federal levels. So that never worked. So I then joined the Nature Conservancy, a not-for-profit, who generate $1.5 billion a year in philanthropy, and that's been very helpful. And philanthropy in Australia is doing well. So I personally, Karen and I donate $100,000 a year to philanthropy to get things to happen on the ground. I would urge you all to think about that. Some of you can't because you don't have a house. Maybe you'll never get one. But, you know, bottom line is don't always have a lot of money. Don't have a lot of money. But if you do get some, then think about philanthropy, because that's the second pillar. But we now think we need 10 times as much money as we're spending on the environment to solve the problem. If we want zero extinctions that the federal government has just promised, we need roughly $2 billion a year. When Brendan Wintel's paper and many people in this room's paper, $2 billion a year, we spend $200 million, maybe. But are we going to get $1.8 billion a year from philanthropy anywhere? No, it's not going to happen. So TNC's view was we need to get money out of the private sector, industry, and those sorts of organisations. The Task Force for Nature-related Financial Disclosures is potentially in the nature repair market, but there's so many problems with many of those ideas, and we've never really quite seen it work. So the industry people keep saying to us, we just need investable business-like plans. Can you deliver us? And there's a language mismatch between what they want and how we deliver them. But I have to say that the Nature Conservancy for 20 years have been working on that, and we've made some headway. Like bought out entire fisheries, re-geared them, re-managed them, sold them on, made a profit. So there's win-win-win outcomes for nature and the economy and people, but they seem few and far between. Water farms is another Nature Conservancy thing where you can fix up catchments, where the people pay for it, or the water utilities, the farmers get money, the water's cleaner, the water utilities make money. They actually save money. So there's these win-win-win outcomes, whether or not there's lots of them, and whether we still don't know who are going to buy these certificates in the nature repair market. So I'm positive about it, because if you've only got 2 dice to roll, you may as well roll them, and maybe we'll get 2 6s. But that's about all I can say. Maybe we'll get 2 6s and maybe something will work. If it doesn't work in 5 years' time, I'm not going to also be deeply surprised. So I think it's worth a shot. Sorry, I have very long answers to simple questions. Yep. We need another. Yes, we do. And then yes. And I know somebody up the back wants to answer questions, so we'll break the two non-Caucasian white males will do.
I'm not sure how I should take that, but anyway, it seems to me that the answer to all these problems is follow New Zealand.
Right. Oh, yes. And do I detect an accent? No. Yeah. Well, I mean, I have to say I'm always very impressed with the Department of Conservation. I think as a government department have been one of the most impressive on-ground conservation organisations. But I know also they suffer funding cuts and they have an enormous number of problems. They do set ambitious goals, but I think, you know, when I said one of the lessons is necessity is the mother of invention. Sometimes you do innovative things when you don't have a lot and things look really, really bad. So, yeah. There's lots to be done. There's a lot to be said. Again, I am a big admirer of many of our small not-for-profits, all the way from Bush Heritage, Australian Wildlife Conservancy, BirdLife Australia. One of the places I donate to is Nature Glenelg Trust. So the United States have about 1,000 small land trusts, 1,000 of them, and they're all occupying and owning and restoring pieces of land and vegetation of 50, 100, 200 hectares. We need more of those small organisations from a grassroots basis and building up the pipelines of investment from those things. So that's something I think we can all work on. Yeah.
Thank you, Hugh, for a very entertaining and insightful talk. I have to admit up front, it's been 40 years since I've done an ecology course. I'm from CSIRO and went in other directions. But I do remember terms, let's put iconic species aside. I do remember terms like apex predators and keystone species. And I just wonder whether they figure into your cost effectiveness algorithm.
Good question. So in fact, the cost effectiveness is the simplest one, and we used to say, I just want to save as many species as possible. And yes, then you literally go to the plants. New Zealand actually said, no, we are going to weight species by their phylogenetic distinctiveness. And so the tuatara gets all these points and kiwis gets all these points, but another grasshopper doesn't do so well. And they had a formula that was actually created by Bob May, that probably the world's greatest theory ecologist and an Australian, developed, and they put that in, and you can just multiply that out. So you're putting a weighting on there, but at least it's a formula that's transparent, repeatable. It can't be fiddled. It's not arbitrarily in, it's multiplying it out. So you might be saying that a kiwi is worth 27 species of grasshopper. But to your point, if you're interested in ecosystem function, what would I be worried about? I'd be thinking, if we lose spectacled flying fox and cassowaries, two of the biggest pollinators and seed dispersers in the wet tropics arguably the most important place in the whole continent, because it has ancient Gondwana and rainforest. Craig Moritz can tell me whether he thinks it's the most important part of the continent from a phylogenetic perspective. So yes, we need to modify those things. And the thing is then, if you can come up with a multiplier that reflects that. So if cassowaries and spectacled flying foxes go extinct, 100 species of rainforest tree will probably slowly disappear. Every tree has about 10 or 20 invertebrates. So you can say they're, 500 species each. Maybe we should put them at the top. And to a certain extent, New South Wales has done that. They've actually picked out half a dozen key species, and they've just said, these aren't negotiable, we'll fund them anyway. And then they've done the prioritisation for the bigger groups down beneath. So that, and actually, to be honest, that's why the formula, the models, whether it's population viability, cost effectiveness, cost utility analysis, Marxan, it starts the discussion, and you get the numbers and you put them down, and then you get some answers, and then you ask questions like you just said. Yeah, well, do I really care about this other small bush or not? And then you say, well, how can I rationally alter the approach to make it a more reasonable answer? And can I quantify it? And can I make it transparent and reasonable? So it is a coffee table. So if there's, there is a message from this talk, isn't there? So non-Australian bit of the talk. It is just bringing people to discuss a common issue and what is the data they need to solve the problem of allocating funds to deliver the best things for conservation. So it's these tools are really coffee tables. And if you walk away from the coffee table just having a better common understanding of the problem, that in its own right is an important part. That said, all the coffee tables in universities have been gone and the tea rooms are gone, and so nobody talks. Is that right? Or they talk through Twitter. Yeah.
We'll just take a couple more questions.
Hi, Hugh. Thanks so much for your talk. So the Samuel review was, released a while ago, and it sat with the previous government for quite a while and nothing happened. And and this government has responded to it. Yes. I was just wondering, what are your thoughts on the response? Like, what are some of the good points? What are some of the bad points? Any of your overall thoughts?
Yeah, I don't think I know enough about the response in detail to say. I mean, to be honest, what I think we're all looking for is a bigger investment. I think some things I like about the response, but I worry about. So when I'm a little bit obsessed with regional planning, I think one of the I think people in this room are already starting to be aware, one of the biggest threats to Australia's biodiversity will be renewables. And it's habitat loss from solar panels and wind farms and all the other infrastructure around those renewables. And if you can look at sometimes some of the maps, if Australia starts meeting global expectations of renewables, we're smelting all the iron ore and all the aluminium, nickel, copper in Australia, which is very smart. It's better than sending the energy overseas. That means we have to produce 8 to 10% of the renewable energy in the planet. 10% of the, and that's a lot of Australia. A lot of habitat destruction in a place like South Australia, it's going to be renewables. How can we actually, so what we're trying to do, and we've been talking about in our centres for a long time, is don't just make a map of all the places you can't put renewables, can we start making maps, not of the red zones? We need to make the red zones. This is the last known habitat of this little shrub, of this little crayfish. Make a map of where to put it that had the least possible damage. So turn the problem upside down. And again, it's not something that environmental scientists always want to do, but if we need another port on the Great Barrier Reef, don't just try and fight it, just acknowledge that one day it's going to happen, but where can I put it so it does the least possible damage? So there's no fighting that we're going to have hundreds of square kilometres, thousands of square kilometres of solar panels. Find me the degraded, already cleared farmland that's hardly profitable in a sunny spot, which is most of the continent, and can we put it all there before we allow the developers to go and fight, and then we're offsetting and chaos happens. So they've said they'll do that. I've been involved in lots of regional plans for biodiversity for forever, for 25 years. And every time it happens, what happens is scientists say we need to spend 5 years collecting more data. We don't have 5 years. So no more new data, no more new theory, no more models. Take what you've got, come up with the best you can do. So, most of my work is pretty rubbishy. So because I run on perfection is the enemy of the good, right? So we just need to get stuff done. Let's develop as fast as possible regional plans because it's threatening biodiversity through housing, infrastructure and renewables. And that's one thing they do sort of say, but the question is, can we get people to go fast? Can we get state and federal governments to cooperate to go fast? Sorry, another long answer. I have so many hobby horses that I can't control myself. Yes. Oh, yes.
Yep. Interestingly, I had a conversation with Hugh earlier where he discussed the gifts that he's received after giving talks elsewhere. He very unsubtly mentioned large gifts of cash. He's going to be particularly disappointed by this evening's gift, but we do want a small set of very highly UC branded, of course, gifts to say thank you for a fantastic talk.
Thank you. Thanks a lot. Thanks a lot. Thank you. Oh, lots of them.
And as Ross mentioned, Charlie Krebs couldn't be with us tonight, but he has recorded a short video message just to wind up the evening. So we'll play that now. And then please come out and join us for food and drinks after Charlie's had his say. Thanks very much.
Good evening. This is Charles Krebs calling in from Canada. I'm sorry I cannot be there with you this evening to hear this lecture from Hugh Possingham. Hugh is one of Australia's greatest ecologists. He has a very excellent reputation for all of the students and postdocs he has trained in conservation biology. He is also one of the world's eminent ecologists. You will have heard his spread of knowledge in conservation biology, and he has had an enormous effect around the world for his contributions. I'm very glad he could come here this evening, and I congratulate Hugh on this lecture.